We don't look at them. We take a look at them. They had to be collected and stored coolly and properly.
Okay. So take me through briefly the research you did and the conclusions you made from it.
Well, we're talking about findings on some tiny chips. We call them chips. These are flakes. And we call them red-grey chips because they're red on one side and they're grey on the other side. It's the red side which is interesting because it shows all the signs of being a thermitic material. I'm sorry I have to use some technical terms here because this is inevitable and I also have to be incorrect. Now thermite, would you let me explain what thermite is? Okay, it is actually an old discovery. It goes back to 1996. The German chemist Hans Goldschmidt.
1896, you mean?
I'm sorry.
Start again. What is thermite?
Well, thermite is an old discovery. It goes back to 1896, when the German chemist called Hans Goldschmidt discovered that a mixture of very finely divided aluminum and finely divided iron oxide, which is rust, when ignited, burns at 2,500 degrees centigrade, which is very, very hot. Actually, it is roughly 1,000 degrees above the melting point of iron, and molten iron is produced in the thermitic process. It's very useful. It can be used for welding. Was patented in 1898 and used in 1899 for welding tram rails in Essen in Germany. But because the iron produced in the process is so overwhelmingly hot, it can always also be used to destruct other items, typically armor. So for that reason, the thermite reaction has been used for military purposes for a long, long time. Now, what we found...
What did the military use it for, exactly?
Well, like torpedoes and grenades. Actually, not so long ago, there was an event in Korea where, according to the official story, a torpedo was... the South Korean vessel was torpedoed by a North Korean vessel. And one of the, as I understand, one of the proofs for this have happened was that the South Korean in the wreckage had found aluminum oxide, which is the other product of the thermite reaction. So this is just one example. But the findings we have found is a modern version of the same, basically the same chemical reaction. The thermite reaction is not a specific reaction, actually, it's a whole family of reactions. But in this case, this material that we have found is a modern high-tech version of which is exploiting the same chemical reaction. And the most pertinent and obvious discovery we found is that the chips are reactive. They still react. We also found some of them which have reacted partly, and where you can actually see the iron being produced in the process. And this is this is unambitious proof that these machines, they're very, very small. We're talking about millimeters and less. So you need a microscope actually to find them in the dust, and some experience and some skill to find them out. But so the research has been difficult because the samples are so small. But there are techniques in electron microscopy where you can investigate this and you can monitor the reaction itself.
What were the main techniques you used to look at those red-grey chips?
Well, first you have descriptive. You're describing the material, basically optical microscopy, electron microscopy, and the various techniques which are used there. And also, as I told you, that the most important observation is the reactivity. When you heat the chips up, they take off. They react. I will not call it an explosion, we do not know. But they react violently and show all the characteristics of a thermite reaction. And this is done in an apparatus which which is called the differential scanning calorimeter. And beyond that, what else can I think this covers the whole family.
And at the end of that, what was your conclusion about what those chips were?
A scientific work, a scientific paper, is a set of data, a discussion of the data, and the best hypothesis you can come up with. And based on the data and the discussion, the hypothesis that we have come up with is that this is unreacted thermitic material, and it has not been challenged. The basic conclusion has not been challenged over the last 2 years since it came out.
I mean, you gave an explanation of what thermite is. People question thermite is an incendiary, isn't it? Not an explosive.
That's correct. Yeah, and you have to distinguish between explosives and incendiaries. And I claim that the controlled demolitions of the 3 high-rises and both incendiaries and explosives were used out of necessity, based on your observations.
So it couldn't have been brought down just by the thermite?
No, because you just watch, use your eyes and be ready to see what you actually see. Regarding the towers, for instance, what you're seeing there, you're seeing steel beams and girders being thrown out and hurled away 100, 200 meters. And we are talking about fragments of tons, 4, 10, 15 tons being thrown 100 meters away like a spike going into the building on the other side of the street. And this means that some energy is involved. You can see the explosions actually running in front of the crush zone as we're talking about the Twin Towers now, how they're being blown up from the top down. You can actually see the squibs running in front of the crush zone all the way down. Some people think that the towers came down by what you call the pile driver theory. So the top actually crushed its way down through the tower.
Like if you dropped a hammer on a plate, that dynamic load.
Yeah, but for once, there is no top section. Just look at the video. There is no top section. Also,
were you looking at Twin Towers, or you're talking about Building 7 now?
No. We're talking about the towers now. Yeah. And we come back to Building 7 in a second.
No top section, I don't understand that, sorry. No.
If you watch, I can show you the video if you will. I suggest you put the video in, like the North Tower, when it collapses, there just ain't no top section. And if you take the South Tower, take the clip taken, the video taken from a helicopter to the south, you can see for once the explosions. You can see the explosions occurring in the top sections above the impact point of the airliner. You can see this top section starts tilting of the South Tower. It starts tilting. Now if something starts tilting, it would continue and actually fall to the ground in one piece. It doesn't. It disappears in open air. There ain't no, and this is only observations. If you make calculations on the energy for the pile driver theory just isn't there. I can give you the numbers. I have in my head, but if you care, how much energy is available, the potential energy, and it just isn't there.
Okay. Stick with your
Building 7.
Okay.
Yeah. What are the indication of explosives and incendiaries? What you see, Building 7 is coming down in perfectly free fall for more than 2 seconds from the start. This is only possible if a whole series of charges have fired with a very exaggerated time sequence and taking out eventually the last supporting structure of the building. When the 47th story starts to move, there is nothing supporting it as it's going down like this. Imagine. This can only be accomplished. And it is the whole building. It's the whole building going down like that. There are 24 core columns. There are 57 perimeter columns all the way down. At that moment, nothing is supporting the 47th floor. And it comes down completely symmetrically. There is absolutely no way this could have happened.
Or it couldn't support the dynamic load above it.
Pardon?
Or it couldn't support the dynamic
47.
load above it.
There's no load above.
There's no load above it. There's no floors above it.
No.
Oh, clearly there are.
We're talking about 7.
Yes, I'm talking about 7.
The 47th floor was the top floor.
Mm-hmm.
There are no floors above the top floor.
No floors above that was just the penthouse. No, of course. But on the lower floors there are clearly is dynamic load working on those that.
Yeah, but the 47th floor, there is nothing supporting it. All the supporting structure is gone at that time. There is no way
you see an internal collapse at the top where the pentagons, you see an internal collapse at the top where the penthouse starts to move down and there's an internal crack, and you see a crack with it, and it goes down from inside.
Yes, I'm not claiming that the whole structure.
So the structure could have been weakened and it could just be collapsed.
Of course. I'm not claiming that the whole structure. Of course not. That the whole structure is taken out like that.
Yeah.
What I'm saying is the last supporting structure is taken out like that. Mm-hmm. I'm saying that at the moment, the seismic track is 18 seconds long. At the moment when the top floor starts moving, there is nothing supporting it. And the whole building is moving symmetrically. It's going all the way down, and building 7 was not hit by an airliner. Now, come on. Okay.
Yeah, I want to go back to your research in a sec, but let me just think as you've raised that question, I want to sort of carry on with that. I mean, do you know of any controlled demolition that's ever been where someone's used thermite as part of that?
No.
Is that surprising?
No. Well, it could be. It's not. I'm a scientist. Listen, and I'm reporting hard evidence. Why? And I'm asking honest. I'm answering your questions honestly.
So
I don't know.
Why would someone want to use thermite as well as a conventional explosive? Wouldn't a conventional explosive be enough?
Go and ask them. You're an investigative reporter. Go and ask them. Mm-hmm. They know.
Who's they?
Who brought down the World Trade Center?
And who would that be? I don't know. You haven't really given me a suggestion who that might be.
They are brilliant engineers. This is a masterpiece.
But who's they?
You find out, and we must have an investigation.
I can't see a motive, and I can't see a person who would want to carry it out.
That's your problem. You have a problem.
Well, I think you have as well, because you don't seem to be able to give me a suggestion of who might want to carry out and who might have done it.
Your problem will be solved when we get an investigation, and the grand jury will find out.
Okay, but you haven't got anyone in mind, right? Okay.
No.
Okay. Okay. So, when you looked at the dust samples you had, the 4 dust samples, how much aluminium did you find?
How much? What do you mean?
Did you do a quantitative analysis of how much analysis?
But this is all actually. Oh, I don't remember the numbers, but this is already in the investigating done by the RGLE group.
No, in your dust, the dust that you did.
But the quantitative contest of aluminum is. Actually, the numbers are irrelevant because we're taking out the chips. We're not considering the dust as a whole.
You're being selective and looking at those particular chips.
Of course.
But you didn't do then on those chips or in the dust. You didn't do any quantitative analysis.
No, because it's already, and this is what started the thing. It's just the original report from the RGLE group, already in 2003 and 2004. And the United States Geological Survey came out in 2005, and they have a complete mapping of the World Trade Center dust, including, and this is quite an extensive investigation, including the total aluminum content. And this is what started Professor Stephen Jones actually and triggered him to look into the dust. Also because in particular this is another finding which is very important. In the RGLE group from 2003, they reported the content of 5.87% iron spheres. These are small particles of iron which are completely round. They shouldn't be there.
Iron or iron oxide? Pure iron?
Iron.
Yeah.
Well, there's aluminum in as well, because of its, the history of its formation, because it comes out in a reaction, in a thermite reaction. But the findings of these spheres on their own is the complete unambitious proof the thermite was also applied during the demolition of the World Trade Center. And this is from 2003.
You did an analysis, looked at how much heat was released by when you heated the aluminium and the iron oxide and the red chips. How much heat was released by them?
Oh, it differs from chip to chip. This comes in.
I think you gave a range, didn't you?
In joules per gram.
Yes.
Do you want me to?
Yes, please.
It differs actually. Kilojoules per gram, and well, the best one comes out at 8 kilojoules per gram as far as I see. And
it's 1.5 to 7.5, I thought.
Excuse me?
1.5 to 7.5, I thought was a range you had. Kilojoules per gram.
Yeah, right. So you know. Okay, very good.
Is that right?
Yeah, according to this, it's the same as this.
Okay. And did you look at any alternatives apart from thermite as being the cause for the red grey chip?
We can't come up with any. That is.
Did you look at any? Did you look for any?
Of course.
So the scientists, did you look to see if there's any alternative explanations?
Of course.
Okay.
We try to come up with the best hypothesis, and it is all in what we call the scientific method.
What else do you look at then? What other alternatives do you look at?
Well, since I don't have any, because
you don't have any.
No.